Welcome everyone to this EWA webinar about the future of water desalination in a changing Europe. This is part of European Water Association activity in preparation to IFAT. What is IFAT? IFAT will take place from May 4th to 7th in Munich, Germany. And IFAT Munich is the most important industry meeting point in the heart of the largest international platform for environmental technology. And then in May this year, we have over 3,000 exhibitors from more than 60 countries that will present their strategy and innovation, discover pioneering solution for water, recycling, and circularity. And EWA is active there. And one of our topic is today's topic, desalination. So we'll have a session on Blue Stage. We'll get back to it after it. And you see here at the bottom left, you can use the EWA tickets to get free daily tickets at IFAT. And as part of today, we will have a webinar on desalination. Few words about us, EWA, European Water Association. So we are an independent, non-governmental and non-profit organization dealing with the management and improvement of the water environment. So we have members from nearly all European countries. We have national members that will represent either utilities, water professional, offer trainings at the national level, setting up technical guidelines, and so on. We have corporate members, such as with us today, for example, Veolia, or research members. And we aim to provide a platform for our members to discuss key technical, but also policy issues at the moment in Europe. And in order to do so, we arrange a couple of events such as today's, but also conferences, meetings, internal working groups, and so on. So you can find more on our website. Quickly, today, our webinar is recorded and will be available on YouTube. You can use the chat function as already some of you are doing, but please use the Q&A box in order to ask you questions and mention also the name of the speaker to whom you want to address the questions to. And we cannot use the raise hand function because all of you are muted as participants and cannot switch on your camera. So today we'll have three speakers. I will speak one after another. And the first presentation will be done by Mr. George Katsansi, Chief Water Officer, Vice Director of the Water Department, Development Department in Cyprus, and who will present the desalination strategy in Cyprus. So George, the floor is yours. So we can see the screen, but you're still mute, George.
Sorry, I was introducing myself in mute, so I will go over again. Thank you for having me today. First of all, let me apologize. The presentation was supposed to be given by Ms. Iliana Tofa-Christidou, which is the Director of the Water Development Department. I was only asked, due to an emergency, I was asked to You can see my screen, right?
We can see your screen. We don't see you. So it's up to you if you want to speak with the camera on.
It's okay. I think for now you can we
okay,
can
perfect.
stick to the presentation, and then during Q&A I can also come up. So I was saying that I was just asked due to an emergency of Ms. Iliana to take over her place. So I will be delivering her presentation. I will do my best to do that, as I didn't even have the chance to go through the whole presentation. But I think we will manage. So the Water Development Department in Cyprus is taking care of all things related to water from the side of the state. So amongst other things, we are producing the water in all different manners, and then we are the bulk provider of the water to the regional water supply authorities, and we're also the retail producer and supplier of the water in terms of irrigation. Okay, so Cyprus is a small island, but has a population of a little bit less than 1 million within the the areas that are in the government-controlled part of the island. It has a semi-arid climate. It faces frequent drought events, and on top of that, we have quite a large population of tourists visiting every year in an always expanding period. We are facing low and unevenly distributed rainfall, and we have very limited number of natural water resources. Basically, we don't have any permanent surface water, no perennial rivers, and no natural lakes. And IPCC characterizes Cyprus as a climate change hotspot island, and we can see this rapid climate change within the last 20 years. So this poses a big problem for us. According to the WEI Plus index in Europe, this is the 2019. There is actually a revised one from 2022, but the result is more or less the same. Cyprus is by far the most water-stressed country in Europe, quite further ahead of Malta, Greece, and other countries which share similar problems. Sorry, there was supposed to be. Okay. Anyway, I will proceed. The statistical analysis of the rain shows that I'm really sorry. I think there might be a problem with the presentation. Actually, I will try to share it again. Oh, okay. Now I see what's going on. Right. So the statistical analysis of the rainfall, the precipitation shows that there has been a gradual drop since the 70s of approximately 15%. But in reality, this translates into an ever bigger drop in the river runoff and the levels of water that we managed to collect in our dams, which is approximately 40%. I'm not going to go into the details of this diagram because it's quite complex, but what I'd like you to keep from this is that the level of rainfall doesn't always translate into an equal average inflow into our dams. In fact, there are years where we have high levels of rainfall, but due to the spatial distribution of the rainfall or different parameters depending on during the time of the year that we have the rainfall and what has happened before that, we don't always receive equal amounts of inflow. So there are times where we can have good rainfall but very bad inflows into our dams. You can see here that the desalination has been, even though desalination has been a big part of the water supply into our systems, the continuous increase in population, tourist arrivals, and water consumption meant that the water supply has not always managed to keep up with the requirements. And a big problem we faced in the past was that when we had sufficient inflows, we didn't keep the desalination plants pumping water into the system, which we now regret. So there's now strategy, the policy change in this aspect, that we will have the units running as long as the dams are not completely full, more or less. Here again, you can see that the annual inflow in the dams and the annual rollfall is quite variable, whereas the actual needs are always there and quite often are increasing. And what is quite important is to note that the drinking water demand has tripled since 1991, as you can see in this graph, which pose an even higher burden into our water supply system. The reasons for this increase are many and different. There's the increasing population, rising living standard, increase in tourism, both in terms of numbers, but also in the terms of the extension of the tourist season, increased water losses from the networks. But what we have found recently is that because of the droughts and the let's say lack of reliability of the boreholes, whenever we connect the community to the public supply, they tend to stop using the boreholes and switching to the public supply, either because the boreholes have dried up or because it's just simpler and more reliable to use those. And of course, the climate change has played a significant role. And recently, as we have to cut the water provided for irrigation, it also seems that people are using drinking water also for irrigation of gardens and fields, putting an additional strain on the system. As you can see in this graph, the irrigation is a big part of the total water consumption, but this varies from year to year, and this is because we cannot always cover the demand for irrigation. In fact, from 1996 to now, we could only cover the full extent of the demand for water for irrigation only in 2 years. So this graph is quite varied from year to year. There are times when actually in 2025, I would say that irrigation was less than 30%, I'm sorry, of the total water provided consumption. The problem is not new. We have been facing this problem since antiquity, I would say. So the big efforts to provide a solution for this started even from the 60s when the democracy was the republic was established. And over the years, we have provided a lot of infrastructure to deal with this problem. The core of our infrastructure is the 100 dams that we have built all over Cyprus in order to be able to collect as much, if not all, of the precipitation that falls into the island, to be able to use it to cover our needs. We have also built 5 permanent desalination plants starting from 1997, and desalination production has become a core part of our attempt to deal especially with covering the requirements for water supply, drinking water supply. As the drought has become even more pronounced the last few years, the last 3 or 4 years, we are now in the process of producing building more desalination units, and we already have 2 mobile desalination units in use, providing an additional 25,000 cubic meters per day. By mobile desalination units, just to avoid confusion, we don't mean that we plan to move them from one side to the other. We're just talking about containerized units, which are easier and faster to set up. We also have 6 water treatment plants treating water from the dams, collected in the dams, with a total capacity of 242,000 cubic meters, plus 9 large sewage treatment plants, which the total daily capacity of 77,000 cubic meters. It's important to mention the sewage treatment plants because Cyprus is leading in terms of the use of reclaimed water for irrigation purposes. We are currently reusing approximately 89% of the treated wastewater in the areas controlled by the Republic. This has happened out of a necessity during the last 25 years, simply because it was the only way to be able to add a reliable source of water for our irrigation needs. This image only shows the number of dams that are scattered around the island. It's the small arrows that you may be able to see. And just an indication that we have dammed almost every location that we could, as I said, in order to keep and use as much water as we can. As I mentioned before, currently there is 5 permanent desalination plants in operation with a nominal capacity of 2,035 cubic meters per day. 2 more were put in operation in 2025, and we have plans to build several more. The plan is to be able to reach a total capacity of approximately a little bit more than 400,000 cubic meters per day, so that we can cover the water supply needs at 100% rate with some spare capacity. The mode of operation of desalination plants, the preferred mode is to have them built as PPP, public-private partnerships under the build, own, operate, transfer contract. In this way, the private companies use their own funds to undertake the design, the construction, and the operation for a fixed period of time, and we pay to receive the water with a unit fee, which is a function of the energy consumption and the fixed costs of the plant ownerships. And in case the operation of the plant is not required, then we pay a standby fee to the contractor so that he can cover the basic costs, let's say. Here you can see more or less how the unit price is made up with capital cost, operation maintenance cost, energy cost, and standby operation and maintenance cost. We found that this works quite well because it provides both the incentive to the desalination contractors to provide a good let's say, quality equipment during the design and construction. And also, they are guaranteed that they will be able to make a profit. At the same time, the government is guaranteed that we will be able to receive the water we need up to the nominal capacity at any given point in time. Here you see a breakdown of the 5 main desalination units we currently have in operation in Cyprus. 4 of them are of the type that I mentioned. One of them, which is owned by the public electricity unit, it's slightly different because they own the plant, but they also provide the quantities in the same manner. And you can see roughly the capacities of each of this unit, the nominal capacity and the minimum daily production that they're required to provide. You can also see the contract unit price and also the adjusted unit price currently, including the electricity tariff and labor index. So you can see the desalinated water in Cyprus is not cheap compared to other areas, and this has to do primarily with the high energy cost on the island. But it is a necessity for us, so we are quite happy that we have the luxury to have this water even at the higher rates compared to other countries. You can see some pictures from our large desalination units here, large for our standards, of course. Might be quite small compared to some of the units in Spain or Saudi Arabia and so on, but they are quite big for us. And as I said, they are the backbone of our water supply. You can see here the Veolia desalination plant, which is the earliest one. It was built in 1997, but what you see here was refurbished in 2000, in the early 2000s. The Larnaca desalination plant is the oldest operating at the moment, and you can see here some images of the then President of the Republic during the initiation of the operation, showing again the importance of these units for our livelihood. The Episcopi desalination plant, the Basilikos desalination plant, which is the one operated by the EAC, the Electric Authority of Cyprus, which I mentioned is owned by them. What is quite important for this unit is that it is taking advantage of the synergies of the fact that it is located within the area of the largest power plant in the country, and it is using the water which is also used for cooling purposes of the power station. So the return of the brine is highly diluted with the cooling water, making it far easier to dispose of it without the need of long and complex pipelines. Here you see the most recent desalination plant, which was built in 2021 and unfortunately was burned down almost completely last year in December 2024. But it was reconstructed fully and put in operation by September 2025. So we have now this essential source back in use. And here you can see one of the two mobile desalination units we built. This one was built in Moni, in Limassol. It was built in 3 months only, with units provided by the UAE. And it is currently providing 15,000 cubic meters of desalinated water into the system. Here you can see that the role that desalination is playing in terms of water supply. So you can see the contribution to the total consumption varies depending on the use of other sources, from 33% in 2020, where we had very good inflows, to up to 76% in 2016. But currently in 2025, even though I do not have the figures, I think it has reached back to levels of 70 or 76%. As I mentioned, the strategy of Cyprus will be in the next few years to be able to reach a capacity of up to 100% of the consumption of water, drinking water. Again, here you can see the different breakdown of the different sources within our water supply. The blue is water provided by the dams whenever the water is there. The light blue is water provided by boreholes, and the red is water provided by desalination. So that you can see that gradually from 1997, where the first desalination unit was brought in operation, up to 2024, the desalinated water has become the main feature of our production of water for drinking purposes. But with this comes a very high cost for the production and use of water, which has increased in the last 5 years only, from 36 million in 2020 to 118 in 2024, even higher in 2025, and in 2026 we expect this to reach 145 billion of euros for desalinated water. And it also has a big effect in the power consumption. All of the units at the moment are being fed with fossil fuels and produce energy, which come up with an estimated figure of 4.2 of the total country's produced electricity. So this is a big burden, not only in terms of cost, but also in terms of energy requirement and, of course, for environmental purposes. The benefits of using the desalination are quite high. Desalination ensures a stable supply of drinking water throughout the year, irrespective of the weather conditions, and reduces the dependence on rainfall and reservoir storage. It meets growing demand under climate change conditions, which reduce the capacity for surface water, and it is a strategic choice for water security for Cyprus. But the challenges, as I said, is very high energy consumption, dependence on fossil fuels, high water production cost, and environmental impacts. Our goal is to integrate within the next years renewable energy sources as much as we can, and energy efficiency technologies to reduce both the environmental impact, but at the same time the cost, the associated cost. So the challenge for the future is to make desalination as sustainable, efficient, and environmentally compatible as we can. I think I've already covered my time. If I'm not,
yes, so it would be great if you could conclude.
I will try to conclude. We are taking all the environmental, let's say, we're trying to be as environmentally friendly as we can to safeguard the environment. We know by checking how the existing desalination units are performing, that other than the impact of the higher power consumption, the impact to the sea is very low, and this is because we are safeguarding both the quality of the brine, that it's reduced, but also we are making sure that all the processes during the process of the desalination are taken care and are done exactly as required in the terms of reference by the contractors. The rest I have already more or less explained. This is a plan of our expected units in the future. We plan to build 2 more large permanent desalination units in Limassol and Dekelia, with a total capacity of around 160 to 180 cubic meters per day, plus several smaller ones to be able to cover, as I said, more than 100% of the total water consumption in Cyprus. And with this, I will thank you for your attention, and I will also show my face now so that you can have any questions.
Thank you very much, Joel. I think we had 3, but we'll move to the next presentation. I think one you more or less already touched upon, and there's during your presentation about the energy inputs requirements. Our next speaker is Adrien Saint-Germain, CEO of Veolia Desalination Activity. Adrien, you lead operations, engineering, procurement, and strategic development to advance sustainable water infrastructure worldwide. Previously, you served as procurement director in the Middle East for Veolia Water Technology and worked as a project engineer and enterprise contracting. And you hold an engineering degree from École Centrale Paris. Your presentation will be on Veolia's desalination activities, focusing on how the company addresses various challenges currently facing the desalination market. Adrien, the floor is yours.
Thank you very much. I'm not sure I can share my presentation.
Yeah. George, please stop sharing and then Adrien can start.
That's the point. Thank you. Since you got used to it, it's perfect. So, good morning, everyone. I'm pleased to talk about desalination. As mentioned a few minutes ago, I'm working on desal since almost 20 years. So I know a bit about the matter. I think the first thing I would like to introduce is how Veolia is focusing its strategy on desal on sustainability. Our world is facing water scarcity, and I think the example of Cyprus is quite clear on that matter. And our mission at Veolia is going beyond than producing water. It's about doing so affordably, sustainably, and at scale. Let's have a look to our, I would say, to our global footprint. We are doing desalination at Veolia since 50 years and more now. We started in the Middle East, and we covered, I would say, geographical footprint that goes from Australia to Europe, through Africa, and even Latin America. That shows that we have been able to face the diverse environment and to bring a solution that fits for the local needs. And that's quite important, and I will come back to it later on. We have a big focus on the Middle East. Middle East is the biggest market for desal, since it's where desal started in the 70s. And still today, it's the largest market that we need to address, and I will detail a bit more on how we do it. The key point I mentioned is about affordability. I think that's the key challenge of our industry, is how to make the price of desalinated water affordable. I would say somehow as affordable as the traditional water could be. Okay, that's the challenge. Our strategy there is to focus on the global cost of water, and I think we see it on the presentation about Cyprus. Looking only to the capex will miss a key point of the equation. We have made some analysis, and we could say that 45% of the cost of desalinated water is about energy. So the first key point at Veolia for us is to working on this 45%. And I can say that we are chasing each and every kilowatt per hour that the desalination process is consuming. We used to be at 20 kilowatt hour per cubic meter in the years 90s with thermal desalination plants. Then we shifted to reverse osmosis plants, and which reduced the bill to 5 kilowatt per hour per cubic meter. And now, by continuously improving our process, we are reaching a limit of 3 kilowatt per hour per cubic meter, which means that in about 15 years, we have divided the bill, the power bill, or the energy bill, by 7. Okay, that's a key achievement in the way to reduce the cost of water. And we continue to work on that key level. The second lever is about the capex, construction and procurement capex. It's about another 40% of the cost of water. We are deploying a design to cost approach to chase each and every dollar, euro, whatever the currency of capex that could be injected in the desal plant. To give you some figure, we used to deliver plants that were ranging between $1,500 and $2,000 per cubic meter of capacity, and we slashed that bill by 2. So a lot of engineering works to reduce those costs and to deliver a very fit for purpose design. And I will say the third level is about operational excellence. Having the most efficient plants would not be enough if you don't operate it properly. And here as well, there is levers made of operational know-how and digital solutions, where we ensure that the plant is operated in a smart way. That's for the, I would say, affordability component. The second component when we are talking about sustainability is about protecting the environment. This is a key challenge for desalination. As you know, the current process, let's make it simple, to produce 1 liter of fresh water, you have to dispose about 0.8, 0.9 liters of brine. So the key question is how to make sure that this brine is not impacting the environment. So we develop process know-how, we develop technologies, we develop way of doing things, and we continuously improve. The key point here is to always be very strict on respecting the local regulation. So each time we deploy a desalination plant, local regulations are applying. We develop models upfront to ensure that the plant, when it will be under operation, will meet those requirements. And practically, in terms of technologies, for example, in Oman, we use the beach wells as intake. The sand is acting as a natural filter, which is reducing a lot the chemical consumption, and as such, the chemical that could have been disposed on the brine. There is another way to reduce the impact of chemicals on the brine by treating them with a specific package on the plant. Another way of managing the dispersion of brine is what we have done in Nomad Crane in rates, where we have implemented a very fit for purpose dispersion design to ensure that by combination of salinity, temperature, and using the current, existing current, the brine is properly diluted and dispersed at the time of discharge. So our strategy is based on sustainable destination. Let's see how we deploy it globally in diverse environments. As I mentioned earlier, the first key area is the Gulf. It's where, if you want to be the leader on the market, you must be the leader in the Gulf countries. So we have a deep focus there. I think we have built up over there something like 7,000 or 8,000 million liters a day of capacity since the 70s. This is the big chunk of the market. The key model we are using and following is the PPP model. Our colleague from Cyprus was mentioning the BOOT model. That's the same approach. It's where we focus on the total cost of water rather than on the capex. It's really where we can deploy our process know-how or engineering capabilities to develop the most efficient plant and the most affordable plant in terms of delivering water. Focusing on XL projects is important to us. First, to lead the race in terms of market, and as well it's because it's where we can have the most impact, where our engineering, our process now is creating the most of value. I will just give you an example. If you take a 500,000 cubic meter a day plant, like the MIRFA 2 plant that you can see on the screen, if you manage to do a 5% saving on the power consumption, so 5% only, you create an upfront value of $25 million. So I would say the bigger the plant is, the bigger the leverage we have to value our process now and our engineering. Two examples are shown on this slide. One is MIRFA 2 in Abu Dhabi. It's a bit more than 500,000 cubic meters a day. And the other one is ASEAN in Dubai, which has already reached the early operation pilots. We are delivering water to the Dubai network, and we are proud of that. This plant is more than 800,000 cubic meters a day, and that will be the biggest plant Veolia has ever made, and the second biggest plant in the world. So it will be a giant, I would say. If we look to another market segments, I would say from 50 to 200 mLGs, we are approaching the market a bit differently. Mid-sized plants are requiring a fit-for-purpose design rather than a standard approach. And here the idea is to combine Veolia WaterTech global capabilities, engineering, and procurement, with water operation local expertise. The idea is to build our strategy on three core pillars. The first is our process and engineering expertise, which will provide the most optimized design based on the local condition. That's quite important. The design will not be the same if you are in South America, in Australia, or in Europe. You have to adapt to the local condition. Then we will deploy our technology portfolio. At WaterTech, we have several technologies that we have built up for the market in the Middle East and that we cannot deploy in other geographies. The idea is to feature a plug-and-play approach that will limit construction cost and risk for our customers. Construction is it's 20% or more of the capex, and it's much more in terms of risk. So it's really something that you have to deal with when you are talking about destination, and having a design a bit more plug and play is a way to control and manage those risks. The third pillar is the operation and maintenance know-how. Veolia has a great knowledge on that field. And when you enhance that with digital solution like Upgrade or like the smart connector, you provide efficiency, reliability throughout the plant life cycle, which is what we are aiming at. These segments will allow us to catch projects in India, Asia Pacific as well is quite active. We have as well Australia, and potentially in South America, a country like Chile is pushing for that kind of mid-size desalination plant. If we go to a smaller segment, that may be what our colleagues from Cyprus are looking for, ranging from 5 to 50 ml plants. Here we are looking for something very standard and scalable. Idea is to integrate our core technologies. So I mentioned the filters for pre-treatment, filters for post-treatment to make potable water. And we have a key innovation there, which is the barrel. The idea is really plug and play, reduce construction cost. Everything is outdoor, no more buildings. You deliver, you plug, and you operate. That's the idea. So faster delivery, reducing construction cost and risk, safer operation and maintenance is your one. And our technology is, I would say, digital native, so it's big as well, levers in terms of operation and maintenance cost. To conclude, I would say that Veolia's desalination strategy is leveraging our core strengths, which are the technological innovation, operational excellence, and geographical footprint. Our idea is not only to deliver desal projects, is to provide sustainable water security to communities, to industries, depending on the local conditions. And I would think that with our energy efficient and cost-effective solution, we are well positioned to maintain our global leadership position on this specific market. Thank you very much.
Thank you very much, Adrien, for your presentation. So again, please use the Q&A box for your question. Please indicate the speakers. We'll now move to our last but not least speakers, Alexander Ferguson. So Alexander, you are an ocean technology entrepreneurs and the founder and CEO of Ocean, a Norwegian company developing subsea desalination systems that turn deep water into drinking water. You hold a business degree from the University of British Columbia, Vancouver, and you previously worked as a venture capitalist in London. You were raised around advanced pumping system in a large industrial workshop. You developed strong practical and technical understanding on how to solve problems with technology. And your connection to the ocean is equally deep. You have a training in marine biology. You have sailed across the Atlantic, and you are an active seaplane pilot and scuba diver. So at Ocean, you brings together experience in engineering, ocean environment, and business to lead the scale-up of subsea desalination and contributes to addressing the global water scarcity crisis. So you will introduce up to deep sea desalination technology, idea, advantage and disadvantage, and upcoming development. So Alexander, the floor is yours.
Thank you very much. I hope you can all both
see. Yeah, we can see everything.
And here, it's great to be here, and thanks for the patience and sticking with it. In brief, I'm the CEO of Flotion. We are a next generation water utility, really building up a new generation of subsea desalination plant where we offer water as a service. Our legacy is very much in subsea water treatment from the oil and gas side. So a lot of the technologies and components have been qualified over more than 1 or 2 decades. And we've had some equipment in the ocean for a while already, producing fresh water from the deep sea, in addition to several pilots. And we are starting our first plant with commercial revenue later this year. So it's great to be here, and we truly see Europe as an important market, together with some of our key partners like Xylem and Siemens Energy and ocean and water impact investors. Recently, we are getting some news, so we are really transitioning right now from an R&D project to a commercial viable solution. So this is very exciting times to be meeting with the marketplace and creating value. We really think the European Union is doing a lot of good things with the water resilience strategy that came out recently. However, there's a lot of things to do. I was recently on the website, and only 2 actions are completed out of 30, and I think there's about 50 actions that the EU wants to do. So the right direction, but things are moving a bit slowly, perhaps. So that's why we're all here to contribute. We are firm believers in traditional desalination and reverse osmosis. It's a great technology, and we think it really has saved lives and helped economic development. But it has some issues, and hence we are representing a new approach, which we're pretty excited about. Here you see a plant which is in the Middle East. It takes up quite a lot of land area. You have a lot of new technologies dealing with intake and outfall, but still there are issues with environmental permitting regarding intake and brine outfall, and you have quite energy intensive plants. Like Veolia mentioned, 45% of the cost can be traced to energy consumption. So these reverse osmosis plants are still quite energy hungry. So another thing is that these traditional plants are exposed to surface events like weather, flooding, storms, sandstorms, algae blooms, and even national security elements like sabotage and so on. Here we see some of the traditional challenges with the traditional infrastructure, and in regards to weather, there's more intensive weather events now than before. So you can really see some exposure to traditional infrastructure, which is increasing the cost and reducing the downtime, reducing the uptime, I mean, of desalination plants. A conventional RO plants, very much simplified, can sometimes be up to 50% of the infrastructure can be related to the pre-treatment of the seawater if it's coming from surface. Of course, it's better if it's coming from boreholes, but the boreholes can be clogged by flooding, and you have quite a land intensive setup. With the Flotion system that we're going to introduce in more detail, it's basically a more standardized solution where you, from the deep ocean, get hydrostatic pressure for free. So that helps to drive the energy down by 30 to 50%. And you also have access to more predictably clean water, so you can really minimize the pre-treatment. Hence, you can be a very efficient plug-and-play solution to traditional infrastructure, or you can offer a completely greenfield solution in a much more distributed way, as opposed to a more centralized way, which is normal for the kind of giga plants where you have a high cost of distribution. So it's really a more simple plug-and-play system. Here you see a bundle where we have 8 pods connected to a single power cable from shore and a single pipeline which is transporting the fresh water back to shore. So all the desalination process happens between 400 to 600 meters beneath the sea level, and this is providing both improved economics, capex and opex, as well as much improved environmental aspect. So the eco-friendliness becomes tremendous in many dimensions. both in terms of lower emissions, because many of these plants are still powered by fossil fuels. You have also much less impact on the ocean environment by not using any chemicals and having a more diluted concentrate on the seabed. We're looking at something like 20% higher concentration of salts in our outfall. So it really quickly mingles with the surrounding seawater at depth, which is also quite far away from most of the bioactive area in the ocean, which are usually in the more shallow areas. So the sort of trifecta we are helping with is really a more economical access to drinking quality water, and it's reducing emissions and it's improving ocean health at the same time. And a lot of sort of clean tech infrastructure, you are really having some opposing forces. But in our case, we really like to think that we're solving for three things at the same time. Significantly helping permitting time and also then the scalability of the solution. So I mentioned it's not just a research project anymore. We are really proud that we have our first system. It's a 1,000 cubic meter per day or 1 MLD system that we are currently building in our own factory. We are implementing that on the west coast of Norway over the next few months and switching it on in June this year. It's the first subsea desalination plant ever built with commercial revenues, and the client is Alvur municipality. So imagine if there's water scarcity on the west coast of Norway, where we're actually having more rainfall than most places in Europe. That says something about the situation. So here it's really for the resilience aspect, as well as industrial development on this peninsula where they don't have access to traditional mountains and rivers. Here you see the site called Mongstad, where there's aquaculture data center in planning. There is Norway's only refinery and a few other exciting sort of green technologies being built. All of them need water, and they need more water than they currently have. So we are excited about that development. And yeah, to wrap it up, this is the picture of how the system looks beneath the sea. We have the desalination pod connected to the pipeline. You have a power connection system here, as well as an ROV. It's an underwater robot. So that is some of the beauty of the technology, is really leveraging more than 3 decades of subsea oil and gas processing experience, where everything really happens using robotics and no human intervention. Of course, this also improves the economics of the system, that there is basically an unmanned desalination plant. So I tried to catch up some of the lost time on the webinar, so I'll conclude there, and happy to take any questions from anyone.
Thank you very much. Thank you very much, Alexander, for the presentation, but also for George and Adrien for yours. Is it fine for you? 5 to 10 minutes max. So we have 8 questions at the moment, so we try to catch them, or we are a bit late. I will start not from the first one in the chat, but we had actually one that was for you, Adrien, but I think that can apply to George, maybe, and Alexander as well. But Adrien, was for you from Regin Ullmann. Since many of your clients in countries with high amount of solar energy, do you include a standard solution for solar power in order to minimize strain on existing electrical power supply infrastructures in your activities? And I think we can maybe reshape it a bit to say same for you, George, in Cyprus, or for you, Alexander, but then maybe Adrien, you first.
That's an excellent question. What we have seen, I would say 10 years ago in the Middle East is, yes, there was initiatives to implement solar solution directly fitted into the desal plant. Nevertheless, this approach has been a bit put aside by the local authorities from Saudi Arabia and Emirates, mainly because that was not the best way to produce solar energy. So their approach now is more to say, industry from Desal, please focus on the way to provide the most efficient desalination solution. And they address their solar demand to a specialized company for producing solar plants. The second topic is that it's maybe not where you implement your desal plant that you have the most efficient area to produce solar power. So the localization is important as well. And again, in Saudi Arabia, they prefer to implement solar plants in the middle of the desert, whereas water plants are on the coastal areas. So there is a disconnect that we see on the Middle East, and we see it as well on Morocco, where practically it's more about wind farm. Wind farm will be implemented in the south of Morocco, and desal plant will be maybe north on the north of the country, like Casablanca, Rabat. So idea of bringing renewable energy in desal is key, and it will go more and more, but not physically connected.
Okay, thank you. George, for you, maybe about on future plans. Do you have any criteria on it?
Sorry, I didn't get your question.
No, I'd say it was about like bringing, let's say, solar power or energy or renewable energy, like maybe for the future plans in Cyprus.
Okay, I would second what Adrian said. We have faced the same problems and dilemmas. First of all, the area that you need to install the solar power, the PVs to produce energy for desalination is quite high. And the land required, usually by the sea, is prime land in Cyprus, which is extremely expensive and very difficult to source. Even finding the location for the desalination plant itself for us can be quite difficult, I would say. So providing the PVs at the same location is very difficult for that reason. At the same time, the desalination plants are operating 24 hours per day. It's very difficult, let's say, to regulate the amount of energy that is being used during the day when you have the maximum capacity of the PVs, and during the night when you still have the same requirements for water production. You could produce, let's say, balancing reservoirs, but then you would need a much higher capacity during the day, and it's not very easy to stop and start the desalination units or reduce the operation levels between these two events. So we need to be more creative and find different solutions. We are looking into other solutions at this stage, including floating PVs. As I said, we have a lot of dams, so we could provide the location for the PVs in that area, which would solve the land area, but it still comes up with two additional problems. One is transferring the energy from that area, which can be quite far away. And the second remains, how do you deal with the difference in the requirements during night and day? We're also looking into pumped storage, which can solve the problem of the night and day. Pumped storage is when you use the electricity during the day in order to pump water from a level to a different one, and then during the time that you don't have the sun, to let the water gravitate and use it to produce energy, hydropower, and use it elsewhere. But we haven't solved all these problems. One thing that is certain is that we are dedicated into using solar energy and renewable energy in general into our future desalination plants, and to a certain extent, as much as possible, into the existing ones.
No, thank you very much. Okay, so do you see a question that you really want to take in the chat, or do I just pick up one as well? I think we had one that came for you, Adrien, again. So it was like, any trends, interest in desalination brine stream metal recovery processes? We know that in Europe, circular economy and everything, 20 topic. Do you have maybe something?
Another good question. There is several initiatives around what we call brine mining. if you look to the literature, you will see that the biggest reservoir of gold in the world is the ocean itself. And that's a fact. Now the question is how to recover that gold, that magnesium, that lithium, and so on and so forth. We have the technologies. We have all the technologies that would allow that. The question is whether we're able to make it economically viable. The more I used to say we produce 1 liter of fresh water and we dispose 1 liter of brine. It's meaning that we have concentrated the salt by half. If you want to recover that salt, you will make your energy bill astronomical. It will be huge and huge. I think we have made studies where this 3 kWh per cubic meter is becoming 10 only to concentrate another time. Divide again by to multiply by 2 again the concentration. So the question is about energy bill and capex. So technologically possible, but not yet economically.
Is it me or did we lose Adrien?
Yeah.
I think we have lost him, yes.
Okay. Okay, let's see. Let's wait. Yeah, Adrien, sorry, we couldn't hear the last part of your question where you say, okay, so doable, but not economically.
Yeah, that would be maybe the key conclusion.
Okay, thank you. Alexander, questions for you. So we can see in the Q&A box a couple of questions here about what you explained, your presentation. So someone just please explain the USP, no chemical use. Some other question about OPEX, reliable, and how do you do the maintenance type of thing. So maybe 1-2 minutes just to complete.
Yeah, so basically the system is designed based on a principle of longevity, so 30-year design life and intervention cycles of 1 to 3 years, depending on the site. So basically we have some redundancy in the system and we have spare capacity in the system. However, when we do want to do maintenance, we pull entire pods to the surface and we do the maintenance on a barge or onshore, the traditional cleaning and replacement. But the quality of the intake and the design philosophy really enables very large maintenance intervals. That's the quick answer. Combined with a low recovery approach, so we're actually recovering only 20-25% as permeate because we're only spending energy on the permeate, not on the seawater. So that's goes hand in hand with longevity as well.
Okay, thank you. Directly just a question that came also, what are the outer limits for your system in terms of distance from shore to 400-500 meters sea level?
The economical sweet spot is within 10 kilometers from shore. We'd like to find minimum 400-meter water depth. And we have identified 95 countries around the world that has high water scarcity as well as these conditions present.
Okay, thank you very much. So if one of you have a question or points that you want to add, please feel free. Otherwise, I will take a question or maybe link to. So we had a question about actually regarding water governance policy and do you take into account social trust, public participation? So the question was especially in region experimenting political social transition, but I will maybe just broaden it up. How do you see the acceptation of like a general public to use desalination potable water? And also someone that I think for you, George, in your presentation, one of the first questions. So if you had, for example, complain about quality of the water that produce or anything. So maybe like, how do you take this into account and ensure that local population is also fine, let's say, to use this unconventional method of production for drinking water?
I mean, the general consensus is that, as I said, we're using more than 70% of desalinated water at the moment for drinking purposes, and there are places where locally it might reach almost 100%. So we don't have any complaints. So with regards to general population, We do have some complaints in specific cases because of the combination of the quality of the water, different parameters that can cause different equipment to malfunction quickly. Usually it has to do with plumbing, especially with solar boilers and so on. And we're trying to deal with this. It's localized, so it has to do with the parameters of the quality and so on. But for general use, I wouldn't say we have much complaints. And speaking from my own experience as well, most of the water in my house is desalinated, and I don't really notice any particular difference.
Thank you. Adrian, Alexander, do you want to add a point? Otherwise, I think some of the rest of the question are done. So as you know, all good. So I will share my screen quickly just to say a big thank you to our speakers and our participants today. So again, this webinar was recording. For the speakers, please do not forget to share your presentation with us in PDF so we can share it with the participants. Thank you very much again for staying the 10 minutes extra with us. Here you can see our EWA program for IFAT, and with and we'll talk again about desalination on Tuesday, 5th of May on the blue stage. So if you're at IFAT, feel free to join, and you could exchange with us and with our speaker as well. Otherwise, you can visit our social media, the YouTube channel where this will be uploaded, our website, our newsletter, and you can register for it. And when you will leave this call, you will have a short survey. Please take the 2 minutes so we can help us to see if this event match you need and to see how to do better in the future. Once again, thank you very much, George, Adrien, Alexander, for taking the time. And we are available if you have any questions of the participants. And thank you very much again. Have a good day. Bye-bye.
Bye-bye.
Thank you.
Right.